We are quickly moving past the era of monolithic single AI agent that try to do everything, as these systems often exceed the abilities of one agent, even it has access to many tools and knowledge sources. That's where multi-agent workflows comes in. These workflows are the blueprint for how specialized AI agents work together reliably, accomplishing a single complex outcome. In this video, we are deep diving into 5 fundamental workflows that industry is using right now, ensuring we cover the use cases, pitfalls, and the implementation details. Our first pattern is sequential orchestration. This is the simplest and perhaps the most intuitive pattern. Sequential workflows chain agents in a predefined linear order. The output generated by agent 1 becomes the input for agent 2, creating a pipeline of specialized transformations. This pattern excels at solving problems that require clear step by step processing, where each successive stage must be built on the work of the previous one. And it closely resembles the traditional pipe and filter cloud design pattern, but here we are using intelligent AI agent instead of custom coded components. Crucially, the next agent to be invoked is deterministically defined as the part of the workflow. The agent themselves are not deciding where the work goes next. Then, when you should use this? You can use it for multi-stage processes that have clear linear dependencies and predictable workflow, and for data transformations pipeline where each stage adds specific value that the next stage relies on, and sometimes for workflows that demand progressive refinement like common draft, review, policy cycle. Now, when you should avoid it then? If stages can be parallelized without compromising quality, or if early stages might produce low quality output or fail entirely, and there is no reasonable way to stop later steps from processing that accumulated error. Now, let's consider this real world example, a law firm automating contract generation. Here is a template section agent that takes client specification like jurisdiction or contract type and select the appropriate base template. Next, this output goes to the clause customization agent, which modifies standard clauses based on the business term, followed by the regulatory compliance agent, reviews the customized contract against applicable laws. And finally, the risk assessment agent that performs a comprehensive analysis of the complete contract, providing risk ratings and protective language recommendation. This predefined sequential pipeline ensures compliance and quality step by step. If sequential is the assembly line, concurrent workflow is a specialized expert panel. This pattern runs multiple AI agents simultaneously on the same task, where each agent provides independent analysis or the processing that often from its unique perspective or specialization. The goal here is speed and the comprehensive coverage. By working in parallel, agents reduce overall runtime and provide diverse insights into the problem. This is often referred as fan in fan out cloud design pattern. In concurrent workflows, agents operate independently and do not hand off results to each other. Their results are usually gathered and aggregated by an initiator agent to form a final agent. This pattern is highly effective for multi-agent decision-making techniques such as brainstorming, ensemble reasoning, or voting-based decision. Now let's see where we can use this kind of workflows. Tasks that run naturally in parallel, whether you use a fixed set of agents or dynamically choose them based on the requirements. Or scenarios that benefit from multiple independent perspectives like technical, business, and creative approaches, and all contributing to the same outcome. And also in time sensitive scenarios where parallel processing is essential to reduce latency. Now let's see where you should avoid it. If the agent need to build on each other's work or require a cumulative order context, you should avoid it. And if resource constraint is there, like model quota limits or parallel processing inefficient, then you must avoid this kind of workflows. Now let's see a real life example of a financial service firm who can use concurrent workflows for rapid stock evaluation. Upon receiving a ticker symbol, the system dispatches the symbol simultaneously to 4 specialized agents. First is fundamental analysis agent where it evaluates financial or revenue trends and competitive positioning. Next is technical analysis agent where it examines price pattern and volume indicators. And third is sentiment analysis agent where it processes news articles and social media mentions, followed by the last ESG agent that reviews sustainability risk and governance practices. These agents are combined quickly to provide a comprehensive time-sensitive investment recommendation. Next, we have group chat workflows, which allows multiple agents to solve problems, make decisions, or validate work by participating in a shared conversation thread. The core of the system is the chat manager, which coordinates the flow by determining which agent can respond next. It manages various interaction modes from free-flowing brainstorming to structured quality gates. This pattern signs in scenario recurring group discussion to reach a decision like a collaborative ideation or formal review workflows. A significant advantage is transparent and auditability because all output from agents and humans is emitted into single accumulating chat thread. It is also highly effective for human in the loop scenarios, allowing an observer or participant to guide conversation or take the chat manager responsibility dynamically. It can be also widely used in collaborative scenarios, where creating brainstorming agents with different knowledge sources build on each other's contribution. Also in validation scenarios, where quality assurance involves structured review process. A specific variant is the maker-checker loop. In this turn-based sequence, one agent, that's a maker, creates a proposal, and another agent, that's the checker, provides a critic. Where you should avoid this then? When simple delegation or linear processing is sufficient, or during real-time processing requirements, make decision overhead unacceptable. But a point to remember that since managing conversation flow can lead to infinite loops, control is most critical. It is often recommended to limit the group chat orchestration to three or fewer agents for effective control. Now let's imagine a city recreation department using this to evaluate new park development proposals. A draft proposals enter the system and specialist municipal agent divide the community impact, where the community engagement agent assesses the accessibility and usage pattern, and the environmental planning agent assesses the ecological impact and regulatory compliance, while the budget and operation agent analyze the construction cost and long-term maintenance. And the chat manager facilitate the structured debate, allowing agents to challenge reasoning. Also, a human employee can participate in real time, adding insights and addressing concerns before the proposal reaches the community for feedback. Moving on to handoff workflows. This is all about dynamic delegation. In this pattern, an agent assesses the current task and decide if it can handle or if it needs transfer control to a more appropriate specialized agent based on the context. The genius of handoff workflow is that optimization is often not known upfront. Task requirements only become clear during the processing that demand intelligent routing. Unlike concurrent workflows, here full control transfer from one agent to the next. The result is a single handoff chain leading to a single result. You can use this in scenarios where tasks require specialized knowledge or tools where the order and number of agents cannot be determined. Also, in multiple domain problems that require different specialists operating one at a time. But you should avoid this if task routing is simple and based on deterministic rule rather than dynamic context interpretation. And also avoid if suboptimal routing decisions could severely harm the user experience. A great example is a telecommunication CRM solution. A customer interacts first with a trial support agent. This agent interprets the request and tries to handle common problems. If it encounters a complex network issue, it hands off the task to technical infrastructure agent. If it is billing dispute, it hands off to finance resolution agent, where each specialized agent operates until the customer success has been achieved or the agent reaches its own capability limit, at which point it might hand off again. Importantly, some agents are designed to hand off the conversation to a human support agent as well when the problems exceed AI capability. Our final and most complex pattern is magnetic workflows. This is designed for open-ended complex problems that have no determined plan of approach. The focus here is not just solving the problem, but building and documenting the approach to solve it. It's centered around a magnetic manager agent that dynamically builds and refines a task ledger, which is a comprehensive approach plan with goals and subgoals. The manager agent iterates, backtracks, and delegates tasks as many times as needed to build a successful plan. This pattern is often used when specialized agents are equipped with tools allowing them to make direct changes in the external system. The documented plan is very crucial here as it can be presented to a human for review before implementation begins. In some ways, magnetic workflows extend the group chat pattern, but it focuses on plan generation and using specialized agent to effect changes in the outside world, not just discuss knowledge. You can use these workflows for complex use cases with no predetermined solution path, or when the AI system is required to generate a fully developed plan of approach that a human can review. And you must avoid this if the solution path is deterministic and if the task has low complexity and could be solved by a simpler pattern. If the work is highly time sensitive and this pattern focus on building and debating viable plan, not speed. Now consider a site reliability engineering team using magnetic workflows for low risk incident response. When an incident is detected, the SRE automation manager agent creates an initial task. First, it consults the diagnostic agent to analyze logs and error pattern. Based on those findings, the manager refines the plan and might consult with the infrastructure agent for recovery option or the communication agent that incorporate stakeholder notification checkpoints. And if needed, the rollback agent is added to the plan. The manager agent continuously refines the task ledger based on new information, even switching the strategy also. It maintains a complete audit trail of the evolving plan for post-incident review. The shift to multi-agent architecture is redefining how we build reliable, scalable AI applications. By selecting the right workflow pattern, whether it is linear refinement of sequential or the parallel insight of concurrent, the consensus driven nature of group chat, the dynamic expertise routing of handoff, or the comprehensive planning of magnetic, you can design complex systems that reliably tackle tasks that a single agent simply cannot. If you find this background helpful, please hit the like button and subscribe to SK Neuron. And let me know in the comments which workflow pattern are you planning to implement the next. Till then, keep learning, keep coding, and keep growing. See you in the next one.